Okay, so today's lesson, I want to talk about what volume means. We're going to determine the formula for volume of prisms. This is much, much easier than the formula for surface area. We'll find the volume of prisms, and we're going to find the volume of composite solids all in one day because this is so much easier than surface area. We're not going to get to number 5. We're just not going to get to it at all right now. It may be something we come back to at the end of the year. Okay, so first, volume is the number of cubic units needed to fill the space inside the figure. So say we had a little tiny block, and that was our unit, and we are measuring how many blocks fit inside of the solid that we are measuring. Okay, that's what volume is. It's the number of cubic or three-dimensional units that we need to fill the space inside the figure. Now, a cubic unit is a cube with edges 1 unit long. So whatever our unit is, if we're measuring in cubic feet, it would be a cube, and all of the edges would be 1 foot long. If we were measuring in cubic inches, we would have a much smaller cube whose edges were all 1 inch long. Okay, now, the formula for the volume of prisms is fairly easy to come up with. I am going to attempt to draw a cube. Let's see here. All right, here's my cube. Now what we're measuring is how many cubic units fit inside here. So I'm going to extend this a little bit. Let's see. It needs to go all the way. There we go. Okay. So what I'm trying to do is figure out how many cubes fit inside of here. So here's 1 cube. And then here's another cube. It's not going to look too good, so I'm just going to draw kind of little square ones here. Okay, so I have 1, 2, 3, 4, 5, 6 cubes across. And then if I kept going, I would have 1 more, 1, 2, 3, 4, and 5 cubes across this way, we're going to say. So how many cubes would it take to fill the bottom of this? David? 30. It would take 30. We have 6 here, we have 5 here. 6 times 5 is 30. Now if I kept going upward with my cubes, okay, let's see how many I ended up with. 1, 2, 3, 4, 5, 6, 7. I have 7 cubes going upward. So if each layer has 30 cubes and I have 7 layers, how many cubes is that? 210. Good. We had to take our 30 and we had to multiply times the number of layers to get 210 cubes. So 200, and obviously I'm not going to draw all 210. My drawing is too messy and it wouldn't look right anyhow. So the formula for volume of a rectangular prism is really easy. You just take the length times the width times the height. That's it. Very simple. Multiply all 3 dimensions. For any prism, what we did with this rectangular prism is we found the area of the base by multiplying 6 times 5, and then we just took that base and we multiplied it by how tall it was. So for any prism, all you have to do is find the area of the base and multiply it by the height. So B stands for the area. Actually, you know what? Yeah, let's leave it like that. B is going to be the area of the base, and H is the length of the segments connecting the bases. What did we use? Maybe we should stay consistent with this. What letter did we use when we were referring to that length of the lateral faces in the area, surface area formula? Anna?
W.
W. Let's stick with W. I don't want you to get W confused with width. I wish they had picked a letter other than W, but I think we better stay consistent. That's how I have it in my notes, and if we use H, I think it's going to be confusing later on. So switch that to W. Okay, any questions about these formulas? Aren't these nice and easy compared to those surface area formulas? A lot less to figure out. Okay, so we're already on objective 3, finding the volume of prisms. Our formula for volume of a rectangular prism is just length times width times height. So we just take 4 times 3 times 5, which is 60. And we put a little number 3 up there to show that we're working in 3 dimensions, and we call those cubic inches. So 60 cubic inches, meaning 60 cubes that have 1-inch sides would fit inside of that shape. Okay, next one. Volunteer to tell me what the volume of this shape is. David?
60.
No, the next one.
Yeah.
72. Good. If we take 6 times 3, we get 18. 18 times 4 is 72 cubic centimeters. Did you guys do volume of rectangular prisms in elementary school?
Yeah.
I figured. Yeah, they're really pretty easy. Most people already know that. Okay, now, when we're finding volume of triangular prisms, we just have to find the area of the base and then multiply it by W. So what's the area of that triangular base? Trey? 6, good. Half of 4 times 3 is 6, so the area of the base B is 6. W is also 6. So what is the volume of that triangular prism? Bryant?
36.
Good. The volume is 36 cubic centimeters. Okay, next one. I want you all to think about this. I'm going to use the cards to choose someone. So start by thinking of the area of this base. Emma, can you tell me the area of the base?
96.
Tell me how you got 96.
I did 8 times 3 equals 24 divided by
24 divided by 2 is not 96. Did you say 96?
2.
What did you say?
I thought I said 12.
You said 96.
But you meant 12. Yeah, you're looking at me like, are you crazy? I didn't say 96. All right, so the area of the base is 12 square centimeters. Okay, Max, what would the volume then be?
144.
Good. We take the area times W, which happens to be the same as the area, and we get 144 cubic centimeters. Okay, any questions so far? Okay, let's look at a couple other shapes. So here we have a cylinder. If you were to look up the textbook formula, if you were to maybe Google, how do you find the area of a cylinder? They would give you a more complicated looking formula, but you can just use volume equals base, area of the base, times the length of that segment, just like we did for the other one. So how do we find the area of the base of this cylinder? Bella?
8 squared.
Good, 8 squared times pi. So B is going to be 8 squared times pi. And can you do that and tell me what you get? You don't have a calculator. I won't ask you to do that in your head. Volunteer for the answer to that. Trey? 296 hundredths, like that. Okay, so that's the area of the base. So to find the volume, we take that times 15. Volunteer to tell me what you get. Reese?
3014.4.
Good. 3,014.4 cubic centimeters. Okay, are there any questions about that? Do we need to do the other one? Okay, let's move on to a trapezoidal prism. Okay, so I would say probably trapezoids are the shape that you guys have the most trouble with remembering the formula for. On the PSSAs, you will be given the formula for area of a trapezoid, and the area of a trapezoid is 1/2 base 1 plus base 2 times the height of the trapezoid. Nathan, tell me how I would fill this in. So B equals 1/2. What are the two bases of that trapezoid?
9.
Good. So we're going to add 9 plus 5. And then what's the height of the trapezoid?
7.
No?
Oh, 4.
4. The height is always perpendicular to the two bases. So the height is 4. 9 plus 5 is 14. Half of 14 is 7. And 7 times 4 is 28. Good. So the base is 28 square centimeters. And then multiplying that times W, which is, Nathan, what's W?
6.
6. Good. Okay, what do we get for volume of that? David? Good. 168 cubic centimeters. Okay, any questions about that? Okay, I'm going to skip the next one. What is this? What kind of prism is it? Parallelogram. I guess it would be a parallelogram. All right, we're going to move right on into finding the volume of composite solids. You're going to like this so much better than finding the surface area of composite solids. We looked at this problem when we were finding surface area, and it was kind of complicated because we had to figure out how many surfaces were actually exposed. When we're doing volume, it doesn't matter because we're finding out how many units fit inside. So all we have to do is count how many cubes we have, find the volume of each cube, and then we know the volume of the whole solid. So it says that each cube has an edge length of 2 centimeters. So what is the volume of just one cube? Bryant?
8.
8. Good. So the volume of one cube is 8 cubic centimeters. How many cubes do we have all together in that shape? Madison?
I don't know.
Well, let's see. We've got 3 across this way and 3 across this way. So in the base, how many cubes do we have? 13 is the total, yeah. You're getting the total. So we'd have 9 in the base, 3 times 3 is 9, plus we have these 4 sitting on top. So we have 13 cubes. So 13 cubes times the volume of one cube is what? 13 times 8. Trey?
104.
Good. It's 104 cubic centimeters. Isn't that nicer? You don't have to worry about subtracting shared things or anything like that. You just figure out how many little cubes will fit inside here. There's going to be 8 in each one of these squares. There's 13 squares, so it's just 13 times 8. Okay, let's look at another example. Okay, so again, these may even be the exact same pictures that we had before. We have to divide this into 2 shapes, find the volume of each, and then we're just adding it together. There's no taking away anything that's shared, we're just adding the volumes together. Let's see, I could divide this a couple different ways. I think I'm going to take this shape and I'm going to go like this. So I'm going to find the volume of, let me just highlight it a little bit here. My highlighter. Nice light color. So I'm going to find the volume of this blue shape down here, and then I'm going to find the volume of, it's a little too fat, but the yellow shape up there. So you have an idea what I'm talking about. All right, what are the dimensions of the blue shape? And I'll use blue to express that. Myra, what are the dimensions of the blue shape? 8, 7, and there's one more dimension.
4.
No?
Oh,
2, yeah. It's 4 from here to here, so the blue and the yellow together are 4, so we have to look at just the blue. So 8, 7, and 2. So how do we find the volume of that? Kayla? Mm-hmm.
7 times 2.
That's it. Good. 8 times 7 times 2. So we should get a volume of 112 cubic feet for the blue shape. Now yellow, I'm going to use orange instead of yellow to write with because yellow won't show up very well. What are the dimensions of the yellow shape? Megan? Two, and 7. Good. It tells us that this is 2. This one, if we look down here, we already know that this blue was 2, so there's 2 left. 4 minus 2 is 2, so this one is also 2. And then the width of it here is 7. So volume of the yellow solid, Jake, how did I find that?
2 times 2 times 7.
Good. And what is that? 28. So the volume is 28 cubic feet. Reese, what do I do to find the volume of the whole thing? Just add them together. So the volume of the whole thing is 112 plus 28, which is what? Good. 140 cubic feet. Okay, your flip chart contains a number of examples. I'm going to skip the ones that are fairly basic. I want you to go ahead to the one where we have the 2 cylinders inside each other. Okay, these ones look kind of scary. If you were finding the first one, okay? Let's see how much. So we have enough time. We'll do both of these together. If we're finding the first one, we need to find the volume of this outside cylinder. So we need to find the volume of, that's kind of written really strange. It's really hard to see that, isn't it? There we go. Okay, so we need to first find the volume of the outside shape. Then we can find the volume of this cylinder. And we don't need to subtract, we're just going to add them together because we're finding the volume of one plus the volume of the other. Now the second example has a hole in the middle. So the second one we are going to need to do some subtracting when there's a hole. So let's start with this one. Let's find the area of the blue shape. What is the radius of the blue cylinder? Casey? Eight. Good. We know that it's 16 all the way across. So from here to here is 16. Half of that is 8. So we can find the area of the base by doing 8 times 8 times pi. We just did that earlier.
Yeah.
What does that work out to be? It's like 200.96. Okay. So that is the volume of the large cylinder. Now let's find the volume of the small cylinder. Wait a second. No, sorry, that's not the volume, that's the area. Wait, let me back up. That's the area of the large, of the circle. Okay, so now we take that volume equals that area times W. What is W for that, David? For the large cylinder? 7, good. So we need to multiply that times 7. What do we get when we do that? You want to do it real quick? 1,406.72. Okay, so that's the volume of the large cylinder. Now let's find the volume of the small cylinder. Michael, what's the the radius of the small cylinder? No. Yeah, it is 4 because it's just showing the segment that's halfway across. So to find the area of the small circle, guys, don't talk. We need to do 4 times 4 times 3.14. What do we get when we do that? 16 times 3.14.
50.24.
All right, 50.24. Now what is W, Michael, for that cylinder?
7.
7. It's also 7. So the volume of the small cylinder is going to be 50.24 times 7, which is what? $351.68. Okay, now what do we do to find the volume of the whole thing, Taylor? Just add them together. And what do we get when we add them together? We're going to have a space here. 1406.72 plus 351.68 equals 53, you said point what? Wait, say it all again.
1,758.
Okay, 58.4. Okay. Do you guys agree with that? Do some of the rest of you do that? Okay. Okay. Last one we're going to look at because it has a hole in it, so this one's done a little differently. We have to find the area as if there was no hole. So if there were no hole, what would the radius of that cylinder be? Avery? Good, it would be 8. So here's the radius. Radius is 8. Guys, enough. All right, radius is 8. So to find the area, we do 8 times 8 times 3.14. And then I'm going to go ahead and multiply by W up here right away. Anna, what's W?
2.
No?
Oh, 4.
4. Good. Okay, when we multiply that all together, we should get, let's see. I don't think I have the right answer here. Someone tell me what we get when we do that. It's not what I have written down here. Bryant?
803.84.
That sounds right. 803.84 cubic centimeters. That's the volume of the whole cylinder. Okay, now we need to find the volume of the smaller cylinder, or the hole. We turn the hole into a cylinder by itself, and then we're going to take that away, and we'll be left with the shell. Angelina, what is the radius of the smaller cylinder? So we're looking at just this hole. 8 is from here all the way across. We need to take away this part. Not quite. Look how far it is from here to here. It would be 6. Because this is 2. 8 minus 2 is 6. So the radius is 6. Angelina, what's W for that cylinder?
Wait, which one's W?
We're doing the purple cylinder. W is the length of the cycle connecting these two wheels. It's actually purple. Blue is over here. See the difference?
Oh, yeah, ditto.
What? No? Megan? It's 4. It's the same as this one. They go back the same length, so it's 4. Okay, when you do that, what do you get? Someone do it. Bryant?
452.16.
452.16. Did someone else do it? Do you agree with that?
Yeah.
Okay, now, because it's a whole, we are going to subtract. So we're going to start with the volume of the whole thing, and then we're going to take away the volume of, let's do it this way, the HOL whole. Okay, minus 452.16 gives us a volume of what? Anna?
351.68 cubic centimeters.
Good. 0.68 cubic centimeters. 351.68.